parallel form realization of IIR filters. So I've been searching for this realization in YouTube, but I couldn't really find a realization which could completely explain to me how to do this parallel form realization. And also I couldn't find a really simple one. Anyway, I'm trying in this video to make this concept clear to you and simple to you. So how to do the parallel form realization? This is an exam point of view video. Let me tell you first. Okay, so the general structure of a parallel form realization is like this. So before going into the question and all, just see the general structure of a parallel form realization. And also before that, I want to tell you that we have done videos on direct form 1, direct form 2 and cascade form realization of IIR filters. This is the next one, which is the parallel form realization. Okay, so I'm going to tell you the general structure. That is, this is how it will look like in general. So we know that there is an input x of n and the block diagram will look like this. There is a c which is a constant value. Then it will be an arrangement of parallel transfer function blocks. This is your transfer function h1 of z, then h2 of z. Likewise, all your transfer functions which can come will be connected in parallel. Then adding all this together, then you will get your output y of n. Okay, so this is the general structure of I'm just drawing a rough figure. So this is a general structure of your parallel form realization. There is an input side, there is an output side, there is a parallel rows of, there's a parallel rows of, there is a first one which is a constant value, then parallelly connecting all the transfer functions which can come in your transfer function if you reduce it. Okay, so this is a general structure of your parallel form realization. Now, if you are given a question like this, how to draw the parallel form structure, let us see. Okay, so anyway, one thing is clear that we need to find the transfer function. Okay, and also we need to reduce that transfer function in the form of constant plus various transfer functions. Okay, I'll write that also. That is, we need to reduce the transfer function h of z in the form c plus h1 of z plus h2 of z plus etc. up to n number of transfer functions. That is, we are going to reduce this complex transfer function as a sum of a constant value plus simpler or smaller transfer functions. So that is the case we are doing here, and also then we are going to draw this in the form of a parallel structure which I have drawn earlier. Okay, so now I am going to do this question. So realize the given equation y of n is equal to minus 0.1 y of n minus 1 plus 0.72 y of n minus 2 plus 0.7 x of n minus 0.252 x of n minus 2. This is a question. And first thing we need to do is find the ISRO transform of this equation. This is a differential equation. So y of n, I'm just writing it directly. Okay, I'll write it once again. Y of n is equal to minus 0.1 y of n minus 1 plus 0.72 y of n minus 2 plus 0.7 x of n minus 0.252 x of n minus 2. Okay, now take the ISRO transform. I hope the ISRO transform is familiar to everyone. So I'm demonstrating it anyway. So if you take the y of n's ISRO transform, it is y of z. I'm using capital letters. It is a general way of using. Okay, minus 0.1 y of n minus 1 ISRO transform is z raised to minus 1 y of z plus here 0.72 y of n minus 2 ISRO transform is z raised to minus 2 y of z plus 0.7x of z minus 0.252 z raised to minus 2x of z. Now we need to form a format y of z by x of z to write in the h of z format or the transfer function. So take all the y of z terms to this side and keep all the x of z terms on the other side. Okay, I'm just taking all this y of z terms to this side, and also along with that I'm taking the common y of z and x of z. Okay, so y of z into 1, this point minus 0.1 into z raised to minus 1 will be plus 0.1 z raised to minus 1. This will be minus 0.72 z raised to minus 2 is equal to, here I am taking x of z is common, x of z into 0.7 minus 0.252 z raised to minus 2. Okay, so we have formed till this. Now we don't need this question. I'm just removing it. Anyway, we only need our transfer function to do the realization. So rearrange it in the form y of z by x of z, y of z by x of z, which is equal to your h of z or your transfer function, which is equal to, how will it be? 0.7 minus 0.252 z raised to minus 2 by 1 plus 0.1 z raised to minus 1 minus 0.72 z raised to minus 2. So this is your transfer function. Now if you have this transfer function, you don't need any of this. I'm just removing all of this. Now our real process of parallel form realization is going to start, because till now we have just obtained the input to realize. So this is the thing we need to realize actually. Okay, so how to do the parallel form realization? I have told earlier that we need to make this complex term into a form c plus h1 of z plus h2 of z plus likewise. Okay, so how to form it? We need a constant term now. How to form a constant term? It is obtained by dividing your numerator, which is this, by your denominator, which is your this term. So in order to get a constant or a number, we need to really divide the numerator by denominator. Now I am going to perform the division. Okay. I know many of you guys doesn't know this. So please have a closer look to see how to divide this transfer function. So what is your dividend? Your dividend is your numerator or the thing which you are going to divide. So it is given in the format 0.7 minus 0.252 z raised to minus 2, right? So what I am going to do is I am going to write the z raised in the form z raised to minus 2, then z raised to minus 1, then plus constant term. So it is minus 0.252 z raised to minus 2, then plus 0.7. I have just rearranged the terms. This is my z raised to minus 2 term. This is my constant term. Similarly, I am going to write this term also in this format. So it will be like minus 0.72 z raised to minus 2, then plus 0.1 z raised to minus 1 plus 1. Okay, I've just rearranged the numerator and denominator in order to perform a division. Now I need to cancel out my z raised to minus 2 term from this dividend or this term. So if you multiply 0.72 with what number, you will get a number closer to this. It is with 0.35. Just have a multiplication of 0.35 with 0.72. You will get a number closer to this. Okay. So 0.35 something. I'm just taking 0.35. So when I have done this problem, I've obtained it as 0.35. So 0.35 into 0.72 will give you, that is 0.35 into minus 0.72 will give you minus 0.252. So it is minus 0.252 z raised to minus 1, sorry, minus 2. Then minus, this is 0.35, right? So 0.35 into 0.1 z raised to minus 1 will be plus 0.035 z raised to minus 1. Then 0.35 into 1 will be plus 0.35. I'm going to explain this term once again. If you don't understood anything, just listen one more time. Okay, so we need to cancel out this z raised to minus 2 term from the numerator. For that, I'm going to consider that which number if multiplied with this term, because this term is also having z raised to minus 2, right? So, if I multiply what number with this point minus 0.72, I'll get minus 0.252 or a number closer to this. If you have a variation in the decimals after 2 or 3 position, that doesn't really matter. So, the value should be closer to this value so that we can cancel out this term. So, if you multiply 0.35 with minus 0.72, we'll get minus 0.252. So, minus 0.252 is raised to minus 2 plus 0.7 by, we'll get minus 0.252 is raised to minus 2. Then, again multiply this 0.35 with this term. You know how to perform division, right? So, 0.35 into 0.1 is raised to minus 1 will be 0.035 is raised to minus 1. And then 0.35 into 1 will be 0.35. Okay. Now cancel these two terms and write the remainder. The remainder will be, so there is no z raised to minus 1 term, right, to subtract. So it is minus, that is I can write 0 z raised to minus 1. So 0 z raised to minus 1 minus this one will be equal to minus 0.035 z raised to minus 1. Now 0.7 minus 0.35 is plus 0.35. Okay, so this is your remainder and this is your quotient. This is your divisor. So how can you write this term? You can write it as quotient plus remainder by divisor. So this is how you can rearrange a fraction by performing division. Okay, so I am going to replace this as a form quotient plus remainder by, I am just rearranging my remainder also. It will be, if I rearrange, it will be 0.35 minus, just to look good, 0.35 minus 0.035 z raised to minus 1 by your divisor, that is 1 plus 0.1 z raised to minus 1 minus 0.72 z raised to minus 2. Okay, so we have written in the form quotient plus remainder by divisor. So how much, that is how can we split this transfer function? First we need to split the denominator, then we need to split the numerator. First I am going to split my denominator as various factors so that I can cut it to smaller transfer functions. So what is my denominator? It is 1 plus 0.1 z raised to minus 1 minus 0.72 z raised to minus 2, right? So I can find the factors of this polynomial. Okay, so what will be the factors? The product is 0.72 and the sum is, so the product is actually minus 0.72 and the product, and the sum is 0.1. What are the two numbers? The numbers are minus plus 0.9 and minus 0.8. Just multiply these two numbers. What is the product of 9 and 8? 9 and 8. 9 8s are 72, right? So if you take the product of 0.9 and minus 0.8, it will be minus 0.72, right? So the product of plus 0.9 and minus 0.8 is minus 0.72. And if you take the sum of these two numbers, that is plus 0.9 minus 0.8 is plus 0.1, right? So these two numbers are obtained. So what we are doing here is we are going to factorize the denominator. So if you factorize this term or this polynomial, we will get the numbers are plus 0.9 and minus 0.8. So I can rearrange or rewrite my denominator as 1 plus 0.9 z raised to minus 1 and 1 minus 0.8 z raised to minus 1. So this is how you actually factorize the z transform equations. This will be associated with the z raised to minus 1 term, and the factors will be multiplied with that z raised to minus 1, because here it is a z raised to minus 2 polynomial. So we will be having z raised to minus 1 and z raised to minus 1. Okay, so this is a factors. So we can rearrange this denominator like this. If you want to multiply, just multiply these terms and open the bracket and you will get the same equation. So this is the denominator. Now we need to find the value of the numerator, so that is we have to split the numerator now. The numerator is 0.35 minus 0.035 is raised to minus 1. We need to now factorize this numerator. So how can we factorize it? So that we can split it as two transfer functions. So how can we do it? That is, in order to simplify this equation, we apply the math rule, that is a by this term, because this is a product. So a by 1 plus 0.9 is raised to minus 1 plus b by 1 minus 0.8 is raised to minus 1 will be equal to this term. Now if you equate it and find the values of a and b, we will get this transfer function, which is a large transfer function, as a sum of two smaller transfer functions. So this will be your h1 of z and this will be your h2 of z. Now we have a format, that is c plus h1 of z plus h2 of z, and finally we can draw a parallel structure. Okay, so now we need to actually find the value of a and b. So this is actually mathematics. I hope these things you have done in your maths. So how to split this? That is how to find the values of a and b. Just cross multiply these two terms and equate. That is a into 1 minus 0.8 z raised to minus 1 is equal to, plus, there's a b term, b into 1 plus 0.9 z raised to minus 1 is equal to, there is a denominator, 1 plus 0.9 is raised to minus 1 and 1 minus 0.8 is raised to minus 1. Okay, is equal to 0.35 minus 0.035 is raised to minus 1 by 1 plus 0.9 is raised to minus 1 into 1 minus 0.8 is raised to minus 1. So you can cancel out these denominators, right? So I'm going to cancel it out. There's no denominators now. Now, open these brackets. A minus 0.8 is raised to minus 1a plus b plus 0.9 is raised to minus 1b is equal to 0.35 minus 0.035 is raised to minus 1. Okay. Now, there are some terms which are constant. There are some terms associated with z raised to minus 1. What you have to do is equate the constant terms together and equate the z raised to minus 1 terms coefficient together. Okay. So the constant terms are A, B and 0.35. So we can write A plus B is equal to 0.35. Also, there is a 0.9B and minus 0.8A with the ISRO raised to minus 1. So 0.9B plus, minus 0.8A is equal to minus 0.035. To solve it, you will get the value of B as 0.144 and A as 0.206. So this is simply two equations, right? This is your equation 1 and this is your equation 2. Solve these two equations. You can do it simply and you can find the value of B as 0.144 and A as 0.206. Now we have a form C plus H1 of Z plus H2 of Z. I am going to write it first, then I will draw the structure. Okay. So this is your H1 of Z, this is your H2 of Z plus, just removing it and writing the constant term, plus C. Okay, so this is your new transfer function. So it should be actually, okay, I'll write it once again anyway, just to make you feel the same thing. 0.206 by 1 plus 0.9 is raised to minus 1 plus 0.144 by 1 minus 0.8 is raised to minus 1. So now we have our H of Z in the form C. The C value is 0.35. 0.35. That is C, H1 of Z and H2 of Z format. Right. Now we have the H1 of Z and H2 of Z. Right. So what we are going to do? We are going to actually draw the block diagram of parallel form realization. Right. So before drawing the parallel form block diagram, this is a final block diagram, we need to actually realize this H1 of Z and H2 of Z using the direct form 2 realization. That is a very simple thing for this equations, because there is only one term, that is one denominator. The numerator is a constant value. So do the direct form 2 realization of H1 of Z and H2 of Z first. Then combine the constant H1 of Z and H2 of Z together and form the parallel form realization. I am going to first do the direct form 2 realization of H2 of Z. Now I am going to do the direct form 2 realization of H1 of Z. What I am going to do is I am going to take this constant and then I am going to just take 1 by 1 plus 0.9 is raised to minus 1. Then finally I will be multiplying with this point, that is 0.206. Okay. So how to do the direct form 2 realization of this H1 of Z? So I have done a detailed video on that. Please do watch that video if you want to get more familiar with direct form 2 realization. So you have to write it y1 of Z by x1 of Z. Since there is no numerator here, or the numerator is a constant value, you don't need to introduce a W of n term. Okay, so all these things we have discussed in that video. So 1 by 1 plus 0.9 is raised to minus 1. Then cross multiply and take the inverse Z transform. So if you do it, you will get y1 of Z into 1 plus 0.9 Z raised to minus 1 is equal to x1 of Z, right? So taking the inverse Z transform, then y1 of n, I'm just multiplying and also taking the inverse both in single step, plus 0.9 y1 of n minus 1 is equal to x1 of n. Okay. Now, I am going to take this x1 of n term to that side. I'll write here to become visible. So, y1 of n is equal to x1 of n minus 0.9 y1 of n minus 1. So, this is a term to get realized. Also, there is a 0.206 at the output side. That is a constant term we need to multiply. So I'm going to draw the block diagram of this equation. So there is x1 of n term, there is x1 of n. Now there is a y1 of n at the output side. Now y1 of n minus 1 term is there, so delay this y1 of n. You will get y1 of n minus 1 and multiply it with minus 0.9. Then plus x1 of n will be your, this is equal to your y1 of n. Also at the output side there is a 0.206 constant term, right? So I'm going to multiply this result with 0.206 to get my y1 of n. Okay, so this is the realization of your h1 of z. Okay, we just remove it because we have already drawn it, right? So this is the realization of your h1 of z, that is this term. So this is a realization of your h1 of z. Similarly, if you see these two transfer functions are very similar. So if you see this transfer function, you can normally draw this transfer function also. You don't need to really go for realization. So anyway, we have to apply what realization here? For this h2 of z also we need to do the direct form to realization. But anyway, this is very similar to the next transfer function also. So we can directly draw. So what is that? x2 of n, there is a y2 of n at the output. So this term will be associated with the y2 of n minus 1. So z raised to minus 1. So this is simple logic you can apply. You don't need to waste your time. That is what I'm telling. y2 of n minus 1 is output multiplied with minus 0.8. So this minus 0.8 will be plus. Since here it is minus, here it should be plus. So plus, so into this and then plus with x2 of n, then your output is coming here, and at the output side you need to multiply with your constant or the numerator. That is 0.144 is y2 of n. So this is your realization for h2 of z. This is your realization for h1 of z. Now you need to combine this h1 of z, h2 of z and the constant term and draw your parallel form structure. Now I am going to demonstrate how to draw that. There is a single x of n, then there is a constant term, and that constant term is 0.35, right? So it is coming to the output side. Then there is a h1 of z transfer functions block diagram you need to insert here. So this x1 of n is actually our x of n in the splitted form. So this you have to draw an arrow to this. So here also an arrow. Then add, there is a, just remove this x1 of n because it is x of n splitted form. So add, then so there is a delay element here. That is, just draw this block diagram here. Then there is a minus 0.9. It is coming to this summer. Then here there is a 0.206. So 0.206. And this is being added with this constant term. Okay. Now we have drawn our h1 of z complete. Now we need to draw our h2 of z with this term or this part of block diagram. So here again you don't need to go for x2 because your x is splitted in 3 branches. So here it is coming, there is a summer, then there is a delay element. Just reproduce this h2 of z here. Z raised to minus 1 here, and it is being multiplied with plus 0.8. Then it is given to this summer, and the output is coming. Now at the output side, you have to multiply with 0.144. Okay. Now this is being added to this one. Now this will give you your, okay, or simply come to this way. So this will give you your output, which is y of n. Now I can remove all these because I have anyway redrawn my parallel structure. Now closely examine this. This is your constant plus h1 of z plus h2 of z format. Now we have taken away all the x1, x2, y1, y2 terms. We only have x and y. And intermediate between these x and y, we have our transfer functions. So this x is being splitted to this constant and these h1 of z and h2 of z. So this is actually your h1 of z. This is your h2 of z. Okay. So you have to draw arrows to all the branches. Don't forget to give arrows. Here also you have to give arrow. Here also you have to give arrow. So this is being added. The constant is being added with h1 of z. Here again this h1 of z plus c is added with h2 of z to give your y of n. Okay, so this is how you have to draw your parallel form realization. So this is how you can draw your parallel form realization. If this is familiar or this is clear to everyone, please do subscribe to the channel. And for more videos, so this is how you can do your parallel form realization. If this was useful for your preparation, please do give it a thumbs up and also share with your friends. And if you want more videos, please do subscribe to the channel.